Alright, so I'm going to first start off by demonstrating how to make a congruent segment. So as you can see, you have your original segment here that you're going to want to replicate. I would just start off by naming both ends of it just so you have like a reference point. I'm going to name my left end A and my right end B. Now you're going to want to take your straight edge and you're going to want to make a segment that is visibly longer than the original one, just with pencil. Okay. And I'm going to want to name my left end A again, just to refer back to this endpoint up here. And I'm going to want to then place my compass on the original segment from one end to the other end. So keeping that distance, and I'm just gonna check here to make sure that it does look good. Yep, that looks like the correct distance. So then I'm gonna place my compass on my left end, so new point A, and I'm going to keep that distance and mark it down on my new pencil segment. Where that arc meets the segment, that's going to be the exact distance from the first segment to now the new segment. Alright, I'm now going to demonstrate how to make a congruent angle. So up here I obviously have my original angle, which I named the vertex point A. And next I'm going to want to take my straight edge and draw a line segment. Make sure it's not too short because you don't want to run into problems later on, and you'll see what I mean. So you'll next want to obviously name your left hand end point A, just to replicate this point up here, A. And next you're actually going to want to take your compass and draw an arc that intersects both top and bottom lines of the original angle. And I'm going to name my top intersection point B and my bottom intersection point C. And I'm going to want to take that distance, keep that distance, and place it on my new segment point A. And I'm going to want to make that same arc, but this time I'm actually going to want to go as far as my hand can. So a little bit past 90 degrees is perfectly fine. Next, I'm going to want to place my compass from the width distance from B to C, so my top and bottom intersection points of my original angle arc, right about there. And I'm going to want to place it on this bottom intersection point from the new line segment, which I'm going to name C. So from C, I'm going to take that width, place it, and draw the intersecting arc. Now, I'm going to want to take my straight edge and draw from the vertex point A to this new intersection X I have up here. And that is how you make a congruent angle. I'm now going to demonstrate how to bisect any segment which you're given. So you're going to obviously start off with your original segment, name both ends, so A and B. And you're then going to want to take your compass and place it on either end. I'm actually going to place it on B because I'm right-handed, so it's easier for me. You're then going to want to stretch your compass so where it's visibly like a lot farther than the middle, just to be safe. You'll understand why in a second. But obviously don't go past A because that wouldn't work. So you're then going to want to use your compass and make kind of like a semicircle. A big arc, as far as your hand can go, is about enough. Use that exact same distance, place it on point A, and do the same thing. What you're gonna end up getting is kind of like the midsection of a Venn diagram. So you're gonna have two intersecting points of arcs up here and down here. Now what you're gonna wanna do is take your straight edge and connect them with your pencil. And there you have it, a bisecting line. I'm going to demonstrate how to bisect an angle. So here I have my angle given, which is named A. So I'm going to take my compass and place it on the vertex A of my angle. And I'm going to draw a compass that goes through both the top and bottom segment. Obviously, like before, we're not going to try and make it too big so that it goes outside of the angle segments. There you go. Always name the intersection points, so I'm naming the top one B, bottom one C. I'm going to take my compass again, and I'm actually going to stretch it wider than it was before when I made the arc for my angle. And I'm going to then kind of take my compass outwards, so facing away from the angle, and draw a arc. So it doesn't really have to be that long, just I don't know, about 2-3 inches of distance. And now I'm going to place that exact same distance that I just did on point B and do the same thing. And they're going to cross, and you're going to want to take note of that intersection point of those two arcs, because that's going to be then drawn back to vertex A with your straight edge and pencil. And there you have it, the bisecting of an angle. Okay, so I'm now going to demonstrate how to make a perpendicular line using a line segment which you're given and a point either above or below that line. So I'm going to start by naming the point which I was given A, just so I can refer back to it later. I'm then going to use my compass so I can draw an arc that'll intersect the line that I was given twice. So kind of doing like a semicircle. It's going to intersect it twice, like I said, and I'm going to name them B and C, those intersection points, so I can also use them. I'm going to then use my compass to finish the step by opening it up as a little bit farther than it was when I originally did this arc. And I'm going to place it on C or B, it doesn't matter, and I'm going to draw an arc, about 2 inches long is fine, just so you can then do it for B as well, or the other intersection point. And what you're going to end up getting is kind of like a cross intersection point, which you're then going to, with your straight edge, draw a line through the point which you were given until that cross. Okay, so I will now be demonstrating how to construct a parallel line given a line segment and a point either above or below that line. So I'm going to take my straight edge and, well, first of all, you always want to name your point. So I'm going to name it point A. And I'm going to take my straight edge and my pencil, and I'm going to draw a line segment that will just intersect the line segment that you were given. It doesn't matter at which angle it is. It can either be acute or obtuse. You just don't want to make it too acute because it'll make things complicated. So I now have that intersection point, which is what I'm going to use. So I'll just name that intersection point B. I'm then going to use my compass, and I'm going to place it on point B, and I'm going to create a arc that stretches from the original line segment to the line segment which I drew in pencil. And I'm going to make sure that that arc is actually closer to the line than where point A is, so you want it like between the distance of B and A. I'm going to use that same width that I just created the arc with and place it on point A. You want your pointy part of the compass on point A, and you're going to use that same distance to create an arc. Try and make it as big as your hand will let you go. Alright, that's good. Then I'm going to take the width of the very first arc I created, so I'm going to name C and D, those intersection points, and I'm going to measure the width from C to D, and then I'm going to place it on the intersection point of the second arc which I created, which I'm going to name E. So I'm going to place my pointy part on E, the new intersection point, and I'm going to use that width from C to D to make a little cross mark right there. I'm then going to take my straight edge and I'm going to connect point A to the new cross that I just did, so I'm going to name that point F. So from A to F. Okay, so I'm now going to demonstrate how to create a congruent triangle from a triangle that you're given. It doesn't really matter if it's obtuse, acute, right? This works for any triangle. So you're going to start off by creating a line segment. It doesn't really matter how long it is, as long as it's visibly longer than the bottom leg, which here in this instance is A to C. I'm then going to take my compass and measure the distance from the bottom leg, A to C, and then place it on my new line segment, which I just created, in order to create a congruent segment. I'll then name my points A to C so that I know that they're the same as the original triangle's distance. I'm then going to start from either point A or point C for the original triangle and measure the distance up until B. I'll start from A, go all the way to B, find that exact distance, and then go back to my new line segment and draw an arc with that distance. About 2 inches is enough, just to make sure that it'll cross paths with the new arc I'm about to make. So then I'll go back to point C on my original triangle and do the same thing, stretch all the way to B, find that distance, go back to my new line segment, go to C, and find that intersection point, right around there. And then I'm going to take my straight edge and just connect both A to that new point and C. Okay, so lastly for today, I'm going to be demonstrating how to do an equilateral triangle of your own. You can make it up on your own. So first you need a straight edge and your pencil, and you can just draw a line segment. It doesn't really matter the length of it as long as it's not wider than your compass itself. And then you're going to want to find the distance of that line with your compass, measure that distance. I'm just going to double check by going to the other end of the line. Okay, looks good to me. So I'm going to name both of my points A and B. And now that I have the distance between them, I'm going to, from point B to A, measure that distance like I had before and make an arc that goes almost to 90 degrees, right around there. Doesn't need to be that far, but it just makes me feel safer about it. And then I'm going to place that exact same distance on A, which will go all the way to B this time, and make that same arc until they intersect. Once they intersect, you can take your straight edge. You might want to name that intersection point like a C. So then I'm going to take my straight edge and draw from A to C, and from B to C. And there you have your equilateral triangle.